Hey everybody. In this lesson, we're going to be talking about solving quadratics using square roots. So we've already talked about solving quadratics in the past. We talked about using the zero product property and then solving quadratics by using the method of factorization. So you guys can factor using the X, you can factor using difference of squares, you can factor by grouping, you can factor using the greatest common factor, breaking stuff apart and then using the zero product property to solve. Well, every now and then, you don't even need to do all that work. Every now and then, you're able to just solve quadratic equations by using the method of square roots, which you have seen before in the past. So now that we know what square roots are and how to simplify and solve them, we're going to be looking at solving quadratic equations using square roots. We can simplify each radical completely and leave the answer as a radical expression. So in the last lesson, you already were familiar with simplifying radicals. So we're going to leave it as simplified radical expressions, not a decimal, even though you could actually check your answer with a decimal. So if you want to go ahead and check your answer at the end, that's totally fine. Um, and then finally, we're going to be exploring what happens when you are faced with taking the square root of a negative number. So what happens in that case? So I'm going to jump right into some illustrations right here. Like I said, so these are kind of like what the example problems are going to look like. I'll do some more examples in a little bit, but it's kind of quick and to the point. If you wanted to solve for this equation, if you wanted to unsquare something, you need to take the square root of both sides. The square root is actually a way to undo the square, the little two on the top. In the last lesson, I explained to you already that there's actually an imaginary two on the outside of this. That they don't really write, but it's actually there. That two is the reason why this two and this two actually cancels. So when you're taking the square root or you're unsquaring something, you're canceling out the square on top. And so if that is the case, so let me erase this, then that means that on the left-hand side, I'm left with x, and on the right-hand side, I'm left with 3. However, when you're unsquaring something, there's actually two options. For example, to get a 9, I can multiply 3 times 3 and get that equal to 9. But also, I can multiply negative 3 times negative 3, and that answer would also give me the value of 9. So there's actually two answers, not just one when you're taking the square root. So if you square root something, um, right after you take the square root, you're also left with a plus and a minus because there's actually two possible scenarios. The answer can be x equals 3, but the answer could also be x equals negative 3. So these are basically the two final answers. But like we say, typically mathematicians are very lazy. So if they could avoid writing something down, then they probably would. So this is the answer that I'm gonna write down. I'm probably gonna leave it in this form. But it actually means this: x is equal to 3 and x is equal to negative 3. Okay. So that was the first illustration, first example. So now, what if we're faced with something like this? X squared is equal to negative 9. Same exact scenario. We can actually take the square root of both sides, right? And then we're left with, okay, the answer for x is equal to the square root of negative 9. There's one little problem with this. We mentioned in the past that when you're taking the square root of something, you're basically having two numbers that are multiplied together to get that number, right? So think of two numbers that you multiply together to get negative 9. Two numbers that are the same number to get negative 9. And the answer to that is that is impossible, right? You can't multiply. If you multiply two positives, you get a positive. If you multiply two negatives, you also get a positive. So there's no possible way for me to multiply two of the same number and get negative 9. For that reason, this will be a situation in which we have no solution. So anytime you want to take the square root of a negative number, it's impossible. You cannot, because by definition, when you take the square root, you want to find two of the same number that multiply to the number on the inside. And if that number is a negative, that's impossible. So no solution. The last example or illustration that I have for you guys is this one here. So same thing. We're going to be drawing the wall. You know how to solve this already from the past. I think it was 8th grade or so. Subtract 4 on both sides. You're going to get 2x squared is equal to 22 minus 4, which is 18. I'm going to divide it by 2 on both sides. And then I'm left with x squared is equal to 9. Now I want to unsquare it, right? So we talked about unsquaring it, meaning taking the square root on this side so the 2 and the 2 can cancel. And then I'm going to take the square root of this side. So my final answer, like I said, anytime you take the square root of something, then don't forget that there's going to be a positive and a negative situation. So the final answer is x is equal to plus or minus 3 because the square root of 9 is 3. Okay, so those are my 3 main illustrations. I'm also going to be doing more examples of these so you get a little bit more practice, and I'm going to be, the last 2 examples are going to be compare and contrast different methods of solving using difference of squares and using the method of using square roots. Okay, so let's jump right into it. So example 1, solve the quadratic expression by using square roots, simplify, and also verify your answer with Desmos. Remember, Desmos we could always use to graph it and figure out where the roots are. Because when you're finding the solutions, you're actually finding the roots. So let's solve it. So we draw the wall, add 20 on both sides, plus 20 plus 20. This goes away. We get x squared is equal to 25. I'm going to unsquare it or take the square root of both sides. So take the square root of this side, take the square root of this side, and I'm left with my final answer as x is equal to, don't forget the plus or minus. There's a positive and a negative option, right, of the answer, which is the number 5. So positive 5 plus times positive 5 will give me 25, but also negative 5 times negative 5 will give me 25. So verify your answer with Desmos. So if we go to desmos.com/calculator, I already did the graphing part for you. Remember, you have to actually graph the equation equal to 0. So what I actually graphed is x squared minus 25 equals 0. This is the part that you're going to be putting in Desmos, right? Not the whole thing, but just this part, not with the equal sign, not with the 0. And if I do that, this is what I get. X squared minus 25. So I graph that to check my answer. I'm going to click on the roots. So there's one root, there's another root. Oh, what do you know? My 2 answers are negative 5 and positive 5. So this is where it touches the x-axis. Therefore, these are my solutions for my roots. So there you have it. So we did one example. Don't have to use any sort of factorization. We're just solving it using square roots. Okay, example number 2. Solve the quadratic equation by using square roots, simplify the radical, leave it in radical form, verify your answer with Desmos. So same idea here. Let's solve for x. We're going to draw the wall, subtract 9 on both sides, subtract 9, subtract 9. I get 3x to the power of 2 is equal to 60 minus 9, which is 51. I'm going to divide by 3 on both sides because it looks like they're both able to be divided by 3. Okay, so I'm left with x squared is equal to 51 divided by 3. That'll give me 17. So I'm left with x squared is equal to 17. Now, I'm going to go ahead and take the square root of both sides to unsquare it. So take the square root of this side, take the square root of this side. So my final answer will be x is equal to, don't forget the plus or minus. So plus or minus the square root of 17. Now, if we can simplify this radical, we should, right? Because we want to leave it in radical form. 17, the only thing that multiplies to 17 is 17 times 1, and then I cannot break up this anymore. So basically, I'm done. This is my final answer. X is equal to plus or minus the square root of 17. So we are done with this problem. However, if you wanted to verify your answer with Desmos, like I said in the past, it only does decimals. So let's figure out what this is in a decimal. So I'm going to pull my calculator out. Let's punch in 17. Oh, what the blazes? Okay, so it's doing stuff on its own again. So there we go. I reconnected the thing. So 17, punch in square root, and then I get 4.123, blah, blah, blah. So 4.12. So my final answer is 4.12. So basically, when I check this with Desmos, x should be 4.12, positive or negative, right? So these two are the exact same answer. So I graph it with Desmos. Notice that I graph the equation equal to 0. So basically, I graphed 3x squared minus 51 because it is actually the same equation, but it's set equal to 0. So when I graph 3x squared minus 51, I get this graph, which is u basically going upwards. There are 2 roots, right? So 2 places where it crosses the x-axis. There is this root and this root. And what do you know? One of the roots is negative 4.12 and the other one is positive 4.12, which is the exact same answers that we got. Okay? So that was example number 2. Positive or negative square root of 17, which is 4.12. Okay, example number 3. Oh, skip too far. So solve the quadratic equation by using square root, simplify the radical and leave it in radical form. Verify your answer with Desmos if you can. So let's do the same thing. So solve for x, subtract 10 on both sides. Subtract 10, subtract 10. I'm left with 2x squared is equal to 160 minus 10, which is 150. I'm going to divide by 2 on both sides. Divide by 2, divide by 2. X squared is equal to half of 150, which is 75. And then finally, I have to take the square root of both sides so I can unsquare this, right? So take the square root of this side, take the square root of this side. On this side, the 2 and the 2 cancel, the little 2 for the radical. So I'm just left with x. On the other side, I'm going to be left with plus or minus the square root of 75. Okay, now I would be done with this. However, I can simplify the square root of 75 a little bit further. So I'm going to go ahead and do that. 75, I can simplify it with a factor tree as 25 times 3, right? 25 times 3, 3 quarters to 75 cents. And then I can simplify this a little more into 5 times 5. I'm going to circle the end of the factor tree, and then I'm looking for pairs. So for every 2, I take that number on the outside. So I have a pair of 5, so that 5 is going to go on the outside, and the 3 is going to stay on the inside. So my final answer is square root of 75 plus or minus, but I could also write this as plus or minus 5 on the outside, square root of 3. So this will be my final simplified radical expression. Okay, now on Desmos, if you wanted to check your answer, it's going to be the same idea. You're going to take the square root of 3. Remember, you always do the square root first, and then you multiply. So I'm going to take the square root of 3 and then multiply by 5. So let's pull out this calculator. We're going to punch in 3, take the square root of that, and then we're going to multiply that number times 5. And then the answer is 8.66. So 8.66. When I go back to this is square root of 3 multiplied by 5. So the answer should be plus or minus 8.66. Okay, so when I check my answer with Desmos, again, I set this equation equal to 0, and then I graph it with Desmos, only the one side that is set equal to 0. So this is what I have. 2x squared minus 150 is equal to 0. So I graph that. I'm going to go ahead and look at this graph, right? It's still a U pointing upwards, and there seems to be like 2 roots or 2 solutions. One of the solutions is right there. The other one is right there. Add negative 8.66 and a positive 8.66, which is the exact same thing that I got. Okay, so you could always check your answer with Desmos if you're wondering if you got it right or not. Okay, 2 more, and then we are done. Or actually, I think I have this one and then a couple more, because you're going to have an additional assignment besides this one and related to examples 5 and 6. So here we go. Example number 4. So we're going to be taking the line, adding 5 on both sides. You're left with 5x squared is equal to negative 200. We're going to be dividing by 5 on both sides. Divide by 5, divide by 5. We get x squared is equal to negative 40. And then, so now all we need to do is take the square root of both sides. So take the square root of this side to unsquare, take the square root of this side, and then we're left with our final answer. But one big problem here. Can we take the square root of a negative number? The answer is no, right? You can't take the square root of a negative number because it's impossible. You can't get 2 of the same number, or you can't multiply 2 of the same number and get a negative. So in actuality, we're actually done here. This is an example of no solution. So you actually cannot solve this because you cannot take the square root of a negative number. So it makes it easier for us. We don't have any extra work to do. However, I still want you to verify this with Desmos. So let's verify this with Desmos to see what that means. So no solution. When I graph this, 5x squared minus 5 is equal to negative 205. So I'm going to add 205 to the other side, and I get this. 5x squared plus 200 equals 0, which means I just graph 5x squared plus 200. This is the graph that it gives me. It's actually a parabola. It's still a U pointing upwards. Here's the only thing. Where does it cross the x-axis, right? It never crosses the x-axis because there's nothing here. That is the reason why we got no solution, and that's the reason why it's giving us the square root of a negative number. So because it never crosses the x-axis, therefore we have no solution, no roots. Example number 5. So after example number 4, you're able to do the first assignment. Example number 5 and number 6 are going to be related to the next assignment that I'm going to give you, which is the exact same thing with an additional step. Okay, so let's say we wanted to solve this two different methods. One of them is by using square roots, simplify, yada, yada, yada. And the other one is we're going to be using the difference of squares to solve this. So I'm going to go ahead and make a table. I'm going to solve this two different ways. One of the ways I already know how to solve is difference of squares. So if I have, let's write difference of squares here. And let's write square roots here. So on the left-hand side, we have 9x squared minus 49 is equal to 0. Some of you guys already realized that this is actually a difference of two perfect squares. This is actually the same thing as of saying 3x all to the power of 2, right? That 2 is going to be going into the 3 and to the x. And then minus 7 to the power of 2. Because 7 times 7 is 49. So what that means is that my two factors are 3x minus 7 multiplied by 3x plus 7 due to difference of squares. So once I factor this, using the zero product property, I'm able to solve this, right? So each one of these parts I can set equal to 0. So 3x minus 7 equals 0. 3x plus 7 equals 0. So when I draw the wall and solve for x, so I get plus 7 on both sides, plus 7 plus 7. 3x is equal to 7. Divide by 3, divide by 3. So one of my answers is x equals 7 over 3. Same thing for the other side. Let's use a different color. So subtract 7, subtract 7. I get 3x is equal to negative 7. Divide by 3, divide by 3. Same exact problem. It's just a negative this time. Negative 7 over 3. So we're done with this answer. We did it by using the difference of squares, by factoring with the difference of squares and then using the zero product property. Now let's do the exact same problem by using square roots. We should be getting the same answer, right? Because it's the exact same problem. So 9x squared minus 49 is equal to 0. I'm going to go ahead and try to solve this by drawing the wall, adding 49 to both sides, plus 49 plus 49. So I get, oops, let me change this color back to black. So 9x squared is equal to 49. Now I want to divide this by 9, divide this by 9, and I get x squared is equal to 49 divided by 9. Now, some of you guys are like, oh, what the heck, 49 divided by 9, that's a weird decimal. Yes, it doesn't go into it nicely. Yeah, big deal. So when you take the square root, one of the properties of square roots is that when you take the square root of this side and you take the square root of this side, you could actually break up the squared root into every single one of the parts of the fractions. So for example, when I take the square root on this side, the 2 goes away. And when I take the square root of this side, that square root could actually be split up into the top and the bottom number. So I can say, okay, this is going to be plus and minus, but it's going to be plus or minus. On top is the square root of 49. On the bottom is the square root of 9. So all I need to know is what is the square root of 49 and what is the square root of 9, and I got my answer. So the square root of 49 is 7. And the square root of 9 is 3. So my two answers are positive and negative 7 over 3, which we knew that because, look, it's the exact same thing that we got by using the difference of squares. And we did the exact same thing here by using square roots. Again, don't forget the positive and the negative, because that means you actually have two different roots, two different answers. Now, just for kicks and giggles, let's verify this using Desmos. So the graphing calculator, 9x squared minus 49 equals 0. So 9x squared minus 49 equals 0. That's exactly the graph that I get. It's a parabola going upwards. If I check my two answers, my two roots, it's actually this and this, positive and negative 2.33. So again, like I said, Desmos doesn't do fractions. So let's just figure out what 7 over 3 is. So 7 divided by 3, 7 over 3 is just the division. 7 divided by 3 is 2.3333 repeating. Therefore, this is actually correct. This is the same exact answer that we got in Desmos, positive and negative 2.333. Okay, final answer, final problem. Same exact thing as example number 5. We're going to be doing the same exact problem two different ways. One of them is going to be by using square roots, and the other one is going to be by using the difference of squares. So I'm going to be using difference of squares on this side. I'm going to be using square roots on the other side. And then solving the exact same problem two different ways, and I better get the same answer. Okay, so on the left-hand side, we're going to get 100x squared minus 1 equals 0. Right hand side, same thing, 100x squared minus 1 equals 0. On the left hand side, I'm going to be using difference of squares. So what I mean by that is the difference of squares property, they both have perfect squares. This is actually 10x to the power of 2, all to the power of 2, minus 1 to the power of 2. Therefore, this is a difference of perfect squares, which means that I can factor it out by using the difference of squares formula, which is 10x minus 1 multiplied by 10x plus 1 will be the factorization of these two perfect squares subtracted. So when I solve each one of these equations, so I basically using the zero product property, so I'm going to be left with 10x minus 1 equals 0. I'm going to be solving this one also, 10x plus 1 equals 0. So my two answers, let's go ahead and solve this. I'm going to get x is equal to positive 1 over 10. I skipped a couple steps there. On this side, same idea, x is equal to negative 1 over 10. So I have two answers, x equals positive and negative 1 over 10, basically, plus or minus, right? That's where that plus or minus comes from. So let's do the exact same problem using square roots. So same exact thing, right? We're going to draw the wall, though. We're going to add 1 to both sides, plus 1 plus 1. We're going to be having 100x squared is equal to the number 1. Then I'm going to divide both sides by the 100. Divide by 100, divide by 100. So we're almost done. X squared is equal to 1 over 100. Final thing I need to do is take the square root of both sides. So take the square root of this side, take the square root of all this side. The square root on the left-hand side cancels out, and the square root on the right-hand side gets split up. So on top, I have 1, and on the bottom, I have 100. But the square root gets split up into the top number and the bottom number, which means that I have to take the square root of each part. So also don't forget that when you take the square root of something, you're going to have a plus and a minus in front of the answer because there's actually two possibilities, right? The positive and the negative. So my final answer for this is plus or minus 1 over 10, which looky, we got the exact same thing here, positive 10 and negative 10. And if you want to be super duper sure that you got the same answer correct, you could always check it with Desmos, 100x squared minus 1. So 100x squared minus 1. I get two answers, so they happen to hit the x-axis twice. The first answer is right there, which is at negative 0.1. The second answer is right there, which is at positive 0.1. And if you check your calculator, 1 divided by 10, what do you think the answer is going to be? 1 divided by 10 is 0.1. So our two answers are negative 0.1 and positive 0.1. Okay? All right, guys. I hope this video was helpful. Hope you guys have a good one. See you guys in the next one.